Hello there guys, and welcome back to another epic inexorable maths video. In this video we're proving Pythagoras' theorem. Okay, so Pythagoras' theorem is a very popular theorem. It states that for some right angle triangle which has got side lengths A and B and a hypotenuse of C, and these can all be in whatever unit you want, meters, feet, centimeters, millimeters, whatever you want, the length A squared plus the length B squared is always equal to the length C squared, like this. This is Pythagoras' theorem. That's the actual formula for it. A squared plus B squared equals C squared. A and B can be either way round in this picture. So I could have written A up here and I could have written B down here. I could have done that. It's totally fine. It's totally valid. It doesn't actually matter. But C must always be the hypotenuse of the triangle, which is the longest side and also happens to be the side always opposite the right angle. The right angle is right there. It's always opposite that angle, and as you can see it's this part here, so that must always be C. A and B can be either way around though, and the formula is A squared plus B squared equals C squared. So how do we actually prove this thing? This is something that is not particularly difficult to prove if you have some understanding of algebra and geometry. There is going to be nothing too complicated in this video in proving this thing, but let's just dive straight into it. So what I want you to do is we're actually going to use this triangle here. So we're going to come back to this triangle in just a moment. I'm going to attempt to draw a shape, and I keep messing it up, so I'm just going to cut to when I've drawn it to a satisfactory level of detail. Okay, I think that's the best thing I'm going to get. So this is a funny shape here, but I'm going to explain why I've drawn it and what it means, and let's label it. So this is supposed to be, if I could draw better, a perfect square on the outside. So the outside shape there is a square, not a rectangle, it's perfect square. And the inside shape, this stuff on the inside, this is also a square, not a rectangle, perfect square. All the side lengths are the same, but it's at an angle, obviously. It's tilted to the side. Now, I've done that for a special reason. I want to label some shapes in here and some lengths. So we're going to say that, do you see how there's a triangle here? There's a triangle here. There's a triangle here, and there's a triangle here. You see that? Those triangles, of course, they must all be right angle triangles because they're inside a square. So these sides must be 90 degrees. Now I'm going to actually use this triangle here, and I'm going to say that actually these triangles that I've drawn on the shape that's on the right is actually going to be 4 lots of the triangle that's on the left. So we're going to say that this length here is A, this length here is B, this length's A, this length's B, A, B, A, and B. Do you see that? Now that means that this length here must be C. Do you see? Because this triangle is the triangle that we've got over here. So of course we're going to say this is a right angle triangle, so we've got the lengths A, B, C, which means that this length is also C, this length is also C, this length is also C. So there's a lot of labels on this, but I hope that makes sense. All it is a big square with a smaller square inside it at an angle, and we have some triangles here. Okay, general size triangle. Now what I want to do is I want to find the area of the big square and the area of the small square. So the big square is the outside one, and if you actually look at it, the whole side length of this entire side of the square, what is it? Well, it's the length that we have at the top, which is the A part, which goes from here to here, plus the length that goes from here to here, which is the B part. So the length of the whole side of the big square is A plus B. And that, of course, it's a square. It's the same for every side. So the area of the whole square, how do you find the area of a square? Well, you multiply the side lengths together. Same with a rectangle. So the area, I'm going to call it capital A, that stands for area. And I'm going to use capital B because that means big square. AB, I'm going to call. That is going to be A plus B times a plus b squared, because a plus b is the length of one of the sides, and it multiplies by itself. Okay, now what is a plus b squared? A plus b squared is equal to a squared plus 2ab plus b squared. That's just from using FOIL and expanding brackets, okay? That's just expanding. Now, what about the area of the smaller square? This slanted one that comes through this area. Well, the area of this square, the side lengths are c, which means the area, and I'm going to call it, I'm going to first of all rewrite that AB, which is the big square, has got an area of a squared plus 2ab plus b squared. And I'm going to say the area, and I'm going to write it as AS, that's going to be the area of the small s, that's where the s comes from, area of the small square is going to be c times c, which is c squared. The reason why that's the case is because the lengths on this small square are c, so it must be c times c for the area of the small square. Okay, now there's still some area missing inside of this big shape. We're missing the triangles. What's the area of these triangles? Because if we can find that out, then we can maybe express the area of the small square in terms of c and the big square in terms of a and b together, and maybe we can get a formula out. So how do we find the area of one of these triangles? Well, we simply use the area for a triangle formula. If we have some right angle triangle, it doesn't even need to be right angled actually, it's just some generic triangle. I will draw it as a right angled one, but it doesn't actually need to be. It can be any triangle. If it has a base b and a height h, the area of a triangle is of course 1/2 the base times the height. Of course, everyone has seen that formula. So we just use that. But instead of b and h, we have a and b. So the area, I'm going to do it on the left. The area of one of the triangles, I'm going to write that as AT, area of triangle, is equal to 1/2 the base, which is A, times the height, which is B. But how many triangles are there? Because it's not just one. There's 1, 2, 3, 4 triangles in this square, inside the big square. So we need to find the area of all 4 triangles. So how do we do that? We times it by 4. So 4 times the area of one triangle, it gives you the area of 4 triangles, which is 4 times 1/2 times A times B, which is equal to 2 times A times B, because this is 4 times by 1/2, which gives you 2 times A and B. So if we refer one more time to, we're almost done, to the shape here, we know that the area c squared is the same thing as the area of the whole big square, but take away the triangles, right? That's what c squared is. The small square is the area of the big square, but not the triangles that go round the sides. So we can say that c squared can be written as the area of the whole big square, which is, we already know that's a squared plus 2ab plus b squared. We already worked that one out. So a squared plus 2ab plus b squared, but not the area of the 4 triangles. The area of the 4 triangles all added together, we know from, again, we've worked it out. It's here. It's 2 times a times b. So we're going to take that away because we don't want the area of the triangles that go around. So hopefully this line here makes sense to everyone. We're all on the same page. Now all we need to do is simplify. Notice how this 2ab, I'll do it in red, this 2ab and this minus 2ab just cancel out. And what are we left with? C squared is equal to a squared plus b squared. And of course, if you want to write the sort of the other way around, you get a squared plus b squared equals c squared, just from swapping the sides. And there you go. That is actually Pythagoras' theorem right there. And we are done. So we can do a little black box, we can write QED, or whatever you want to show that you've just proved Pythagoras' theorem. There are lots and lots and lots and lots and lots of ways to prove Pythagoras' theorem. Some of them are very complicated. This one is not very complicated. It's very easy. And this is my favourite proof of Pythagoras' theorem. Thank you guys so much for watching. Like, subscribe, share with your family. See you in the next video.